Okay, we're going to do an example of using the law of cosines to solve a triangle that is not a right triangle. So this is a triangle that we're given one side AB, the angle A, 20 degrees, and the other side AC. So we have side, the angle between, and another side. This is SAS. Which means this is a good candidate to use the law of cosines for, because if we recall, the law of cosines is a squared equals b squared plus c squared minus 2bc times the cosine of a. So the things that we know in this case are b, that's this c, that's 5, and angle a, that's 20 degrees. So it's a straight, the prompt is asking us to solve the triangle, which means that we're going to have to determine the missing side A and also the two angles, angle B and angle C. So that's what it means to solve the triangle. Find all of the sides and all of the angles of the triangle. So step one, we're going to find out what side A is. And then you're going to see me use the law of cosines to figure out angle B. And then once we found angle B, likewise I could have done angle C. Once we find this angle, then we're going to be able to find this one just through the fact that they have to add up to 180 degrees. So using law of cosines, let's put in the things we know. We've got a squared equals 8 centimeters squared, 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 20 degrees. And from here we just calculate this all out. We've got 64 plus 25 minus 40, 80 cosine 20 degrees, which is, this sums to 89 minus 80 cosine 20. And that's what a squared is. We have to determine this is approximately equal to, my calculator, 8 squared plus, or 89 minus 80 cosine 20. I'm going to make sure it's in degree mode first. So this is approximately 13.82425. And then I'm going to take the square root. That's going to give me A is approximately equal to square root of the answer, which is 3.718. That's what this side length is here. Okay. So I'm going to store that answer into my calculator because I'm going to need it later. And if you forget how to store, you press this STO button. I'll show you right here. You press STO and then put it into a variable, and then you hit enter. And so that's going to set this letter A in my calculator to the number 3.718. Okay. So how are we going to find angle B? Simply, we're going to use the law of cosines with this angle and then the three sides that we know to figure out the missing angle. So let's reformulate the law of cosines, and instead of using A here, which we know, we're going to use B. Okay. And tomorrow, after this one, you're going to see another method for finding angle B that uses the law of sines that might be a little bit faster, easier to use, but both will work. Okay. So let's reformulate the law of cosines using angle B. So what changes when we use angle B instead of angle A? Well, this is B now, because it's the side opposite the angle you know. It's what you're solving for. So that means that these B and C are now A and C. So A and C, A and C. So that's the reformulation of law of cosines using angle B. Okay, so I could right here plug in all the numbers I know, but I'm going to do something first, which is solve for the cosine of B and show that get cosine b by itself first, then plug all the numbers in. So solving this algebraically for cosine b means I need to undo everything being done to cosine b. So that's, well, actually a tricky maneuver first is to move this 2ac cosine b over here and move the b squared over here as a first step. And you'll see why I do this in a minute. 2ac cosine b, and I have to subtract b squared, subtract b squared. So that's going to give me 2ac times cosine b equals a squared plus c squared minus b squared, like that. I basically just moved this whole term to the left to make it positive, and the b squared to the right. And now I just simply divide both sides by 2ac and get cosine b by itself. A squared plus c squared minus b squared all over 2ac. So now we plug in the numbers that we know. So this is going to equal, this is a squared, which is 3.718 squared, which is a in your calculator, plus c squared, which is 5, minus 8 squared, or this is 25 and this is 64. And then all divided by 2 times 3.718 times 5. And that's the cosine of b. So we're going to calculate this number and get what it's approximately equal to, and then take the inverse cosine. We have a squared plus 5 squared minus 8 squared. And all divided by 2 times times a times 5. This is approximately negative 0.677. So now we take the inverse cosine of the answer, and that gives me that b is approximately equal to 132.6 degrees. Cos inverse this guy, cos inverse this guy to get b by itself. 132.6. So now that we know angle b, we're going to use the fact that a, b, and c all have to add up to 180 degrees. Let me see if this actually showed up on the, and there we go. Okay, so you can see the right over there. We inverse cosine both sides. So now let's use the fact that 20 plus 132.6 plus c equals 180 degrees to solve for c. Minus 20. And that's going to ultimately get us c equals 27 point, was approximately equal to 27.4 degrees. 27.4 degrees. And that, there we've solved the triangle. It's good to make sense, or to double check that it, in fact, the sides, the angles match up with the sides, meaning the largest angle is opposite the largest side, 132 is opposite side length 8, 20 is opposite side length 3.718, 27.4 is opposite side 5. So it is true that the largest side is opposite the largest angle, smallest side is opposite the smallest angle. So that triangle makes sense. And it also obeys the triangle inequality, which is that the smaller sides add up to a number greater than the largest side. If that wasn't true, then it wouldn't be a triangle. But there's our triangle. It's been solved.